Hello everyone, welcome back to my channel. Today we are going to talk about another AWS service known as S3. So a couple of you might have already heard about it. If not, don't worry, let's see what it does. I'm taking a small use case over here. Let's say I want to design something called ChiragTube. It's basically the next YouTube. I'm not building it. I can if you guys help me out. Uh, but let's say what basically is YouTube, right? It is something where you post, you create profile, where you upload pictures, videos, thumbnails, right? And let's say it initially has only 10 users. What am I going to do? I'll have something like I'll have a front end, I'll have a back end, I'll have some storage. Now, let's say it starts to scale up, right? From 10 users, if we go to 1,000, then go to 100,000. At this point, and you can imagine YouTube or Instagram, something like that over here. Users are going to be uploading 4K videos. They'll have images, they'll have PDFs, they'll have audio files. There could be any number of things that, depends on whatever you are allowing. Now, the whatever storage that I was using, let's say it was getting stored at some hard drive, right? That is going to become full at some point, right? Let's say I initially got 20 terabytes, right? Maybe it survived 100,000 users, but now that I'm 100,000, it's gonna get full, right? What do I do? I can buy more storage, and somehow configure that get away for a while, but uh, I don't want to keep managing this, right? I mean, it gets harder to scale up, and uh, at this point, I also need to start thinking about availability, duplication. I'm sure you guys have already gone through this sometime, but like you would have some hard disk which got corrupted and you lost your data. Now, I don't want my users to face that, right? That uh, brings down my reliability. So that is where Amazon S3 comes in. It is basically nothing but a very big warehouse of storages. You upload files. Now that file could be anything, any format, video, photo, text, CSV, anything works. And then S3 handles the storage, the replication, the durability, and the scaling. So you don't have to worry about it. You just need to, you know, use that for your application, and AWS, takes care of the rest. So S3, you can just imagine like a big warehouse, and inside a warehouse, you have some boxes or some shelves, right? So this warehouse, it has some containers which S3 calls as buckets. So you basically build a bucket inside of your S3, and that is what is going to contain all your objects. And every file that you create inside it is an object. So that file, it doesn't have a specific type. Again, it can be of any format, but in terms of S3, it is just called an object. Now, what kind of services does S3 actually provide you? So S3 provides you versioning. So if you worked with, let's say, Excel or Google Docs, you would have seen versions get stored over it, version 1, 2, 3, and you can retrieve older versions. So that is true. So let's say you have five objects right now, you upload one more, a newer version would get created. But for some reason you want to go back to the older version. So that is accessible in S3. Then it provides you storage classes. Now what exactly these are? Uh, a lot of the data that you will store in S3, you might not want to access it that frequently. So let's say you are working in a let's say uh, in a payments business, something like Stripe or um, Paytm, right? And they have lakhs and lakhs of records of payments. Now, uh, now they can't really delete that because it's financial records and they might get audited. They might want to go back and see their reports. So that's why they generally don't delete it. So, and let's say I'm creating duplicates in S3 to keep as backups. But they don't need to access it every day, right? Maybe once a month or once every few weeks. So that's why Amazon provides you with multiple storage classes. Depends on how what kind of retrieval you want. If you want frequent retrievals, generally you would go with FC standard. If not, then they provide something like a standard IA, which is infrequent access, and then there's Glacier. The major difference between these storage classes is the retrieval time. This can maybe reply in a couple of seconds. This may take a couple of minutes. Glacier can take a couple of hours as well. So that's one thing, but the cost significantly reduces. If you're working with Glacier, that's going to cost a lot less than S3 standard. The last part that I think this is one of the most common use cases. This is for this I'll also try to show you a demo, and this is what you're seeing in the diagram over here. This is a multi-part upload. When you upload, let's say when you upload a video to YouTube or some other service, right? A video could be up to a couple of GBs, let's say a 20 GB video. So generally, when you're trying to design an API, what you would do is user would send everything to the server, server would send everything to the respective storage. Now the thing is, because pictures and videos they can be very big, uh, there are a lot of cases where it might fail. So for example, it uploads up till 95%, it fails, and then you might have to start again. Uh, And then, of course, if you're transporting it across from your user to your server, it takes up a lot of your bandwidth as well, and the network becomes the bottleneck. So, what you do over here is you tear down your video into multiple parts and you start uploading them parallelly. And only the part that fails, you give that a retry, and the rest get uploaded. And in this case, you also delegate some responsibility from the server to the user itself. So you most likely don't send your video to the server because that could be too big, right? You don't want to move in everything to the server. One other problem with that is, let's say it takes 10 seconds to upload the video sequentially. So what does the user do in that meantime? For example, if I log in to the YouTube, I to tell my server upload this video. It tells me, okay, this is done, but only after 10 seconds will the server know if it's done correctly or not. So does it need to come back after 10 seconds and tell the user? I mean, that's not a great user experience, right? So what we do is we break it down and then we start uploading everything parallelly. So the sequence kind of looks something like this. A user will tell the server, I'm going to start uploading, and the server will respond back with some upload ID. Now, for using this upload ID, I will tell the server, please generate me some URLs. What these URLs are basically the resources where I will start, which I will use to upload my video. So let's say I have 20 chunks. Uh, the the server will give me back 20 chunks, and for each chunk, I will parallelly upload my video directly to S3 over here. And once I'm done, once I know it's all done, I'll tell the server, okay, I'm done. You can stop this process. You can tell the S3 it's also done. And you can store some metadata in your database as well so that it's easier for your next retrieval. So, before we jump into the demo, whenever your application needs to store files, reliability, and it needs reliability at a scale, images, videos, etc. S3 is generally for service you're going to use. And you can have a lot of other things as well over here. For example, you can connect this to some Lambda function which might have some processing like generating thumbnails, transcripting. All that can be done. We'll get to that in some other video when we talk a little more about the architecture. But for now, I'll just quickly try to show you a demo. And let's see. Not this. Yeah. And, so this is just some front end I created. I'm not particularly good at creating this. So let's skip this. We'll come here. So this is just gonna take a video. It can take anything. I'm going to show it to you with a video. I have some over here. Let's see. This is the one. We'll go to inspect over here, and I'll try to show you what it does. Once you click on confirm upload, so what's the first thing? It's gonna ask for a upload ID. Okay, cool. We'll, it started upload, and what it get in the it sent the video and the file name, and it did get any response. It would have. I think I did not print it over here. That's fine. But anyway, this is the upload ID. It it creates consists of 89 parts because I've divided the file into a couple of chunks of 5 or 10 MBs. We'll get to that later, and it creates some key. And then these 89 parts are going to get uploaded parallelly. Okay, I can skip this. And this is what you see over here. These are a couple of calls that are getting, these are the chunks that are getting uploaded parallelly. So if you see the header over here, it's a put request. It has some very long header, and it is basically, uh, you know, trying to upload my video, my chunk. One thing to note over here is this key tag. We'll get to that in the end. And after that, I just tell my backend that the upload is completed. This is the upload ID. These are the e tags. I told you we'll get to it in the end. But we tell this to the backend, and then this is the upload ID. Great. Now did it actually upload? So I have my bucket open over here, and if I go inside the bucket, you can see today is June 20th, it's 11:43, and over here it just uploaded the video. So what exactly happened? Let's try to look underneath the hood, try to get a little more into the code. Um, so this this is my front end. What my front end is doing is it's taking in the file, and we don't need this. Okay, so the chunk, it's 10 MB. My bad, I think I mentioned 5 earlier, but it's 10 MB. So if the video is, I think, 890 MBs or something, so 890 divided by 10 would be about 89 parts. So we try to upload a file. What we do is we make a request to start upload with the file name and the content type that you can decide on the payload later. That's totally fine. Um, we from the backend we would get an upload ID and a key. What do we do? We print out the number of parts. How many parts do we actually? How many chunks do we want to upload parallelly? And then we tell our backend for whatever upload ID and key you gave me. These are the number of parts that I want to upload. So in our case, it was 89 as we saw. And I'll wait for my backend to return me a couple of pre-signed URLs. Now, what these pre-signed URLs are, they are nothing but temporary URLs that my S3 is providing that are authorized for my use, and I'll use these to get access to my S3. Now, I could have provided it with the credentials, but that's very unsafe. That's why these pre-signed URLs exist. They are temporary lived, and they can be accessed only by the client. Now, once we have these URLs, what are we going to do? We are just going to, loop over all these URLs, and then we are going to start uploading the chunks, right? So there's some logic on how I get the start and the end of the file. So you can go check this out later. I am not going to get into this, fairly easy. But the chunk is basically file.slice, start from end, whatever the end is, start and end that are computed from here. Um, okay, and then we we make a put request with the chunk. And what do we get in return? The e tag and the part number. And then we tell S3 what it is completed. This is the upload ID, this is the key, and this is the part number. Now, uh, what is e tag? What's part number? Well, let's talk a little more about that. You get to my backend code. Uh, Create an S3 client over here. Some cores. You can. This is fairly straightforward. This is a big starter function that I created just to see if my S3 is working or not. We can skip this. And yep, this is the one. So when I start an upload, I am, basically I got the file name and the content type from the request. I created a key. This key is going to be unique so that I know what file or what, um, like this key is basically telling me go to the uploads file, and create this uploads folder and create this file. And then I use this multipart upload command with the bucket name, the key, and the content type, and it returns me an upload ID, which basically helps me identify to that for this request, this is the ID for this is the unique ID that you are going to use to upload your video or the object. Then the get URLs, this is the most important part. This is where we generate multiple URLs that the client is going to use. So it tells me how many parts, right? In our case, it was 89. So we try and create 89 parts, 89 pre-signed URLs, pre-signed temporary permissions from the S3. That 89 times I'm going to perform this upload operation. And whatever you are providing me, it needs to expire within this time range. If not, if I use it later than this, please throw an error. And we need to throw this error because otherwise, you know, you can clients can use this URL for a very long time and keep sending requests to the S3, which we do not want. And in the end, when we complete the upload, what are we trying to do? We are trying to tell the S3 that this is completed. When this is completed, we have the key, we have the upload ID, and we have the multi-part upload parts. Now, what exactly this is, I'll show this to you. And where did it go? In the parts, I'm telling it e tag and part number. This is what I'm passing over here. Now, what exactly is e tag and what exactly is part number? So part number basically tells, okay, this is the first chunk, this is the second chunk, and so on. And we went up to 89 over here. So, so because we're parallelly uploading it, right? So it means that there's a possibility that part 10 gets uploaded before part 9. And that's true for all 89 of these parts. They can get uploaded in any order. So how does my S3 know what order to, store it in? So that is why we need to provide this part number that tells us this is the sequence in which you need to store it. Because at S3, it's going to, take all these separate parts and combine them back together. So we need to make sure that the part number is correct. And now, why e tag is generated? I mean, is part number not enough? Well, one simple reason is multiple users can be doing this parallelly, right? I mean, you and I both can be uploading parallelly, both will get part number one. So this e tag also helps you, provide some sort of unique ID that tells you that tells part number one for what upload ID. So all of these, the key, the upload ID, the e tag, the part number, all of these combined provide you enough uniqueness for the S3 to know what video or what object that we are talking about. Cool. Now this is more or less about the upload part. Now for the download, what you're going to do is when you I have not created that right now, but when you click on any video, it will have this. Let's say you store this upload ID or the key in your database along with some other metadata. When the user clicks on it, you send a request to send a request to S3 that this is the ID for which I need to access something. Now again, you can follow the same infra that uh, Over here, you give this ID to the user and tell it, this is the ID. They send a request to S3 and start fetching it back. In the same similarly, you can generate presigned URLs for each chunk. That process more or less remains the same. The one interesting thing with this chunking process is, um, like in Netflix, if you have a 1 hour long movie, you don't necessarily start from zero every time, right? You might start from minute 20 or minute 40. So it doesn't have to download everything, right? It calculates what chunk do I need to fetch it from minute 20. And then it sends a request for that particular that particular chunk itself, and that is what is returned from S3. So that's kind of an optimization that you don't have to download the entire thing. You just download enough what is needed by you, and that's pretty much it. And one small homework for you: try to implement the download functionality. I'll provide you the link to the this code. You can fork the repo, and this if you just need to implement one single API that's gonna download it. And if you do, feel free to share a pull request or feel free to share the approach that you use. And that's pretty much all you need for S3. That's one of the major use cases for S3, uploading images and videos. I hope you guys followed along and you were able to understand most of it. And it's not the easiest thing. I mean, there's a lot when it comes to when it comes to all these cloud services. Uh, the best part is, you can just experiment with it. Like there's general purpose buckets, there's directory buckets, there's vector buckets. I mean, if you work with AI, you know that you have create embeddings, which are basically vectors. So this is specialized for that. There's file systems. There's what kind of permissions your bucket will have. There's a lot you can do around here, and uh, you kind of need to keep playing around with it to understand what it really does. So please try to do that. And there's a lot you can find in this documentation on how to use or configure your buckets, how to use the SDK. A lot of the code that I've written was taken from here. So please go through it and see you guys in the next video. Bye.